Hi guys, this what you see is a 12 volts power supply and this is a 12 volts motor. This motor is usually found in cars for cooling their engines. A link to buy this power supply will be in the description. As you can see here that the power supply is set at 3 volts, so I have to set it at 12 volts with the potentiometer knob. Time to test it. Now guys, this power supply can give output from 2 volts to around 16 volts DC with a current maximum rating of around 17 amperes. So here I'm using this high current supply to test this high current motor. Well guys, as you saw that the motor was running really smooth and at a very high RPM. So let's measure its current with the help of this multimeter of mine. Link to buy this product will be in the description. This motor is drawing really high starting current 20 amperes with a free running current of around 5.5 or 6 amps. So if we take it as 6 amperes, then the power being wasted under no load condition is around 72 watts. Well, here we are with the motor and my grandfather's hammer. Now comes the first instruction. First, you have to open the locks. As you can see that I have already cut the locks with the help of an angle grinder. Okay. Usually there are 3 locks. 1, 2, 3 and 4. This one had 4. Okay. So after cutting the locks, you will have to hold the upper portion and hammer it from the shaft downwards like this. Wow. Well, here what we have is a really nice looking armature and with a really big diameter. I mean, diameter is big but the length is small. Okay. As you can see guys how beautiful the winding is. It's almost new. Well, the upper bearing has gone bad. It's not that smooth. A little oiling and it will work great. The field, as you can see guys, they have used 4 magnets. It's a 4-pole motor. The magnets also look really nice and almost new, but the motor is in good condition. That's the final thing. Time to take it off. Okay. Wow. 4 brushes. No wonder the high current that it draws for no load running condition. You can see how thick the copper wire that is being used here. Although the brushes are like almost new. Yeah. Now comes our final armature. The commutator is used a little bit. It is in good working condition. The lower bearing is very smooth. So let's remove the windings from the poles. So guys, now we have to find out which coil has to be opened first. 2 windings, outermost windings, this one and this one, because it's a 4 brush 4 pole motor. So we can choose any of the 2. Let's look at this one. This is the outer pole and this is one end of it and this is the other end, and this end is in connection with the coil below it. So we have to open this one. That is the only possibility, and you see that it has an open end. Okay, so let's do that. Well guys, if you look closely, I have created a little space. Okay, now I can remove the wire. As you can see, this wire is out. Let's place a mark on the slot that I've just opened. Okay. Well guys, it is almost done. Well, as you can see here guys, that it's a 0.56 mm wire, so no wonder it can carry huge currents. And in this 4 brush type of setup, 2 wires act as one, so it is more than 1 mm cable. So yeah, the target is complete. This armature is completely free of the windings. Now all I have to do is like rewire it with thinner cables and then see how efficient it is. And these wires, these I'm going to use in the 2 brush DC motor because they are really thick and they are going to produce some good amount of current when I modified the thin type of motors with these thicker ones. So anyways guys, see you in the next one.